Okay, so adding and subtracting radical expressions. We can look and see from the properties here. So if we have two roots that match, they have the same part underneath the root, and they're the same index, then we can add the coefficients. So in this first case, we can add a and b together, whatever that is, only if they match. And same idea with subtracting. Okay. So on these examples, we're asked to simplify, if possible. Okay. And we need to assume all variables represent positive real numbers. So we're going to assume that everything is positive, which just means we don't have to worry about absolute value, right? So on the first one, 9 root 7 minus 15 root 7, because they both have matching root 7s, you're going to subtract the 9 and the 15. So 9 minus 15 gives us negative 6. And don't change the root. The root stays the same. You're just subtracting the coefficients. On the second example here, we have a cube root of 5 and a square root of 5. So what do you think? Do you think we could subtract those? No. And so this is as far as we can go without a calculator. And so we just stop there. Okay. So you have to be very picky when you're adding and subtracting it. The root has to match exactly. This third example, 3x square root 72y plus 4x square root 72y. They both have square root of 72y. So we can add the coefficients, the 3x plus the 4x, which is 7x, square root 72y. Okay. Part of the instructions, the simplifying, is not only to add or subtract, but if you can simplify that radical further, go ahead and do that. And 72, well, there's quite a bit there. I'm assuming that, well, at least let's check to see if we can simplify that further. So 72, we break that down to 9 times 8. 9 is 3 times 3. 8 is 4 times 2. And 4 is 2 and 2. So we have a pair of 3's and a pair of 2's that we can take the square root of. So we already have a 7x out front. The square root of 3 times 3 is 3. Square root of 2 times 2 is 2. And we're left with the remaining 2 when we didn't circle underneath the square root sign. And we still have the y underneath that square root sign. And then we can multiply what's out in front. 7 times 3 times 2 is what? 21 times 2 is 42. Okay, so sometimes you'll add, but don't stop there. See just to check if you can simplify further. On this fourth example, the cube root of 16, cube root of 81 don't match up, right? So can we subtract them? No. But could we simplify anything? Probably. So let's try to break down the 16 and the 81. And for right now, we're just treating them like two separate problems. So on the left-hand side, the 16 breaks down to what, 4 times 4. And we're looking for sets of 3 things. Sorry, that's 2 times 2 and 2 times 2. So we get a set of 3 2's, 1 remaining. And we already had a 3 out in front, so this is going to be 3 times 2 times the cube root of 2, or 6 cube root 2. Okay? Minus, well, let's work on the second one now. 81 is 9 times 9. 9 is 3 times 3. And we're looking for a set of 3 things. We already had a 2 out in front. We can take the cube root of 3 times 3 times 3, which is 3, and we're left with cube root 3. So we end up with 6 cube root 2 minus 6 cube root 3. Well, 6's match up, so can we subtract them? No, because we have to look at the cube roots. They both are cube roots, but one's the cube root of 2, one's the cube root of 3. So we're stuck there. That's our answer. Sometimes you go through this process and the roots will match up and you'll be able to subtract them. Sometimes it won't happen. Okay. So try this next one. Simplify. Right now, nothing matches, right? But go ahead and simplify each piece. So you got 3 different problems to simplify, and see if you can combine them at the end. Okay. Take a moment. Try this one out. So for 250, cube root of 250. We break that down, what, to 25 times 10. 25 is 5 times 5. 10 is 5 times 2. And so we have 3 5s. We can take the cube root of, and you end up with 5 root 2. Sorry, 5 cube root 2. For 54, it's 9 times 6. 9 is 3 times 3. 6 is 3 times 2. And so we have a set of 3 3's that we can take the cube root of and get 3 cube root 2. And so we see that, okay, we're going to be able to add those first 2 terms because they both have a cube root 2. And then the third one, 16, break down to 4 times 4, 2 times 2. And we got a set of 3 3's that we can take the cube root of and get 2 cube root 2. And originally as a subtraction problem, so we got a subtraction problem here. So all 3 of the cube roots now match. And so we can just add and subtract the coefficients. So 5 plus 3 is 8. 8 minus 2 is 6. And so we end up with 6 cube root 2. Okay. Try the next one. Okay, so on square root of 50, Tatiana, what did you get when you, or how'd you do that? Just do the square root of 50 for us. What'd you do? Okay, so 5 square root of 2 is equivalent to the square root of 50. Perfect. And then Haley, what'd you do with 3 square root 27? Good. So there was already a 3 out in front, and you pull the 3 out, and so you multiply those together, you get 9 square root 3. Perfect. And so far, the first 2 we're not going to be able to add together because one's the square root of 2, one's the square root of 3. But we have one more to look at, the square root of 98. And Jacqueline, did you do that part? So what does that become? Okay, good. And so, can we do anything else, or do we stop there? Is that the answer? Or do you think we can do anything else to finish this? Can we add any 2 things or subtract any 2 things? First and last, yeah, they both have the square root 2. So 5 minus 7 is negative 2 square root 2. And then that plus 9 root 3, we just leave alone. And that's as much as we can do. Okay. So it works the same with variables as well. And I think we saw that earlier. But here, we got 6 times 2 root x. There's nothing else we can simplify in that first part. And then 5 times the square root of 8x. Well, that 8 we can break up to 4 times 2. 4 is 2 times 2. So there's a couple 2's we can take the square root of. I'm going to rewrite this as 6 square root of 2x minus 5 times 2 times the square root of 2x. And 5 times 2 is 10. And again, the square roots match. And so we can do 6 minus 10, which is negative 4 times the square root of 2x. All right, so there's 2 more like this. Go ahead and try them both. Okay, so on the cube root of 16x cubed, just that first part, Sierra, can you do anything else to that, or is it already simplified? Okay, so you broke down this to 4 times 4. And then that became what? Cube root of 2. Okay. And so we had 3 x's as well there. We were able to take the cube root of those. Good. Minus, and then we have the 4 times the square root of 8x cubed. Kale, can you simplify that part? Okay. Okay. Okay, so the 8x is coming from 4 times the 2 you pulled out, and we pulled out an x. So we got minus 8x square root of 2x. Okay. And can I go any further, or do I need to stop there? Stop. Because one's a cube root, one's a square root, and then even what's underneath the root signs doesn't even match. And so that's as much as we can do. Okay. And then the last one that we worked on, Braden, simplify the first one for us, the square root of 36 x to the 5th y. Okay, because you already got a pair of 6's. Okay, so 6x squared, square root of, good. And then plus, we have the 4x squared, square root 64xy. Zoe, how would you break that one down? Okay, and the 32 came from, what were you doing to get the 32? Okay, so we already had the 4x squared, so 4 times 2 times 2 times 2, and we had the x squared on the outside, and then the square root of xy. And so, yeah, when you multiply that together, we get to 32. So 6x squared xy plus 32x squared xy. And then can we add these together? Yes, they both have a square root of xy. So we add the 6x squared and the 32x squared. When we add those, well, 6 plus 32 is 38. X squared plus x squared, is that x to the fourth or x squared? Just keep it x squared. Yeah, good. All right. Sometimes when you're working with square roots, you're going to want to get rid of them. And we saw that yesterday, right? When we were working with fractions and we wanted to rationalize the denominator, we wanted to get rid of the square root in the denominator. And one trick to get rid of square roots, or one thing that always happens, is if you multiply two things together that are called conjugates that have square roots. So conjugates are binomials, meaning there's two terms, and everything matches except one has a plus sign between them, and the other one has a minus sign between them. And whenever you multiply those conjugates together, you always get rid of the square roots. That's kind of a hint for our next lesson that we're gonna need these conjugates for where we're headed. So here's a couple examples here of conjugates, and let's just see what happens to them when we multiply them together. Okay. So in the first example, we're going to just distribute 6 times 6, 36. 6 times the square root of 12 is 6 times the square root of 12. Can't multiply the 6 and the 12 because one's a root and one's not. Negative square root of 12 and 6 is negative 6 times the square root of 12. And then negative square root of 12 times the positive square root of 12. Is that going to be positive or negative? Negative. And then we end up with multiplying the 12 times 12 inside that square root. But when you do that, you get a pair of 12s, and you can take the square root of that piece. So once we simplify this, all those square roots are going to go away because the two middle ones, when you add them together, you end up with 0. We start with 36 minus, and we're able to take the square root of 12 times 12 and just get 12. So this comes down to 36 minus 12, which is 24. Okay. So it always works. When you multiply conjugates together, it gets rid of square roots. It doesn't get rid of cube roots or other kinds of roots, but it works with square roots. So try the next one. See what number you get. It should be an integer. So here, square root of 3 times square root of 3 is the square root of 3 times 3. Or you could write the square root of 9, or you could just write 3. Okay. But we're going to be able to get rid of that square root. Square root of 3 times the square root of negative square root of 5 is going to be negative square root of 3 times 5. Or you could write 15 there. Plus square root of 5 times the square root of 3. And then positive times a negative is negative, and you get 2 5s. The middle two, when you're multiplying conjugates together, the middle two should be the same value, just opposite signs. So they should add up to 0, always. So here we get the negative square root of 15 plus square root of 15, which adds to 0. This is 3 minus 5, and so we get our negative 2. So very nice to work with conjugates. Just to give you a kind of a hint where this might be helpful is if we have a fraction like this, 1 over square root of 3 plus the square root of 5, and I say to rationalize that denominator, right? And you got to come up with what we should multiply by. What are you going to choose? What's that? Any idea? what would you multiply that denominator by to get to get rid of all the square roots? One right here, square root of 3 minus the square root of 5, because that's the conjugate, and you know it's going to give you -2, and it works out nicely. So we're not doing that this lesson, but that's what we'll be doing probably on Tuesday. All right, last one. Determine whether each expression is equivalent to 3 root 25y minus 7 square root y, and select yes or no for each expression. Okay. So the different expressions on the left-hand side that go down that column here may be fully simplified or maybe partially simplified. It doesn't matter. You just need to know, are they equivalent or not? A good way to start this is just to start with the original and start working through the steps of simplifying that. And along the way, kind of keep your eye open and just look and say, hey, as I'm simplifying, do I see any of these in that step or the steps as I'm going through that? And as you do, then you can hit yes, or sometimes it'll be obvious it's a no. And so let's just start that process here. So we got 3 square root of 25y minus 7 times the square root of y. You guys see anything we can do to start simplifying this? 25s, 5 times 5, pair of 5s, and then when we pull that out, we end up with 15 square root y minus 7 square root y. And let's just check, do you see anything that looks like that? Yeah, first one, right? So we're going to hit yes on the first row. Then let's keep going. 15 minus 7 is 8. We get 8 square root y, sorry. And then let's see, do we see that? Yep, right here, last row. And before we mark no on all the others, let's just check. Let's see if we can, what's 11 minus 3? So this is the same thing as 8 square root y, so we also want to take that one. How about the -4 square root 25? How do you know it's no? There's no y at all, so we know it's a no. And we could say the same for the other, it has no y, and now we've gotten through them. So you just got to take your time through this, make sure there's a reason for why you're putting yes or no for each of these. Okay. All right.